There is an interesting aspect I would like to mention here. In the sim.m file, in the third statement, resume is equal to 0 is the default value that we have set. Till now, we didn't do any function. We didn't see it do any particular function. Let us now see what is the objective of using that resume variable and why it is so useful. Whenever a simulation is performed, this last state.mat gets created automatically. So this file basically contains the information of the last time step state calculation. It is stored in the mat file. So this is used under certain cases and it's very helpful. You can delete this, it will get created again. Let me show you. Let me delete this. I will delete this. So let me get back to the simulation. The simulation, it is still in model, it is in RLC. I will run the simulation and you will see that the plot outcomes. But look out for, I'm going to close this, look out for this last state.mat will always get created. Where is it useful? Now if I go to the sim.m file, look at the third line. Resume is equal to 0 is the default value. When you say resume is equal to 0, it implies that the simulation will always start from t equal to 0, afresh. But if you set resume is equal to 1, then it will start from the values taken from the last state.mat file that we just saw. That is here. It will start from this last state.mat file which had stored the previous simulations last computed state values. So you will see a seamless continuity in the waveforms. And this is very powerful because when you're doing a very complex simulation which can run for long hours, you stop the simulation after that and close down and then get back and then restart the simulation with the resume command. You will begin exactly where you left off. And that can be used as a good reference point for you to do further simulation works from that point onwards. You don't have to every time repeat the simulation right from t equal to 0. So these are the advantages that you would gain by using resume is equal to 1. When we run the simulation with resume is equal to 0, we get the waveforms here. We have discussed this. There is one aspect that you need to note here, last state.mat. This last state.mat gets created, which actually stores the final time calculated values of the states and the time in this mat file. So every time a simulation is run, this last state.mat is updated. So that contains the previous immediate past value of the states. So using these values as the initial condition, you can actually resume or continue the simulation repeatedly. So if you make resume is equal to 1, If we make resume is equal to 1 here, then execute the simulation. Then all the initial conditions of the states will be taken from the last state.mat file, and T naught will be the final value of the previous simulation set, and all calculations will be done from there on. So in this way, if you are having a very complex simulation running for several hours or even days, then you can, when you stop the simulation, the last state will the last state.mat will contain all the information necessary for it to resume, even if the computer switches off, even if there is a power shutdown. Whenever you switch back on and use resume is equal to 1, it will continue from where it left off. Now this is a very, very significant advantage, especially for complex simulations. Let us see how this works. Now let me expand this plot window. The x-axis scale is spanning 0.1, 100 milliseconds. So at 60 milliseconds, we see the input Vs transitioning from high to low, 10 volts to 0. Now let us say that we keep the final time, end time, at 0.05 or 50 milliseconds. So you should see that the simulation should end here. And if I put resume is equal to 1 and continue, the simulation should seamlessly continue from here onwards the second time round. So let us see if that happens. So first what I will do, I will set resume is equal to 0, meaning let it start from 0. I will change the final time to 50 milliseconds. All else remaining the same. I'll save this. Model file, everything is same. See that the model file, this is 1 as long as t is greater than 10 milliseconds and less than 60 milliseconds. So in the first iteration, it will go only up to 50 milliseconds. So let us now simulate this. Sim. So when you simulate this, see here, the end time is 0.05, 50 milliseconds. The input is high all the way up to 50 milliseconds, because only at the after 60 milliseconds are over, the input will come down to 0. Now if I put resume is equal to 1, note that the voltage should start exactly from here, just above the input line, just above 10 volts, and the inductor current should continue from wherever it left off, and this simulation seamlessly should run. So let us see what happens. Now I am going to do this change of making resume is equal to 1, which means I am asking the simulation tool to make use of the initial condition as stored in the last state.mat file. So let us run the simulation. So you see that all the values, state values, input values have continued. Let me expand this from where they left off. The voltage just above 10, it has continued, and the input has continued from 10, and when it reached 60, it has come down, and so on, all the other variables. So you see that this is such a powerful feature that one can have resume a simulation not many simulation packages offer, but this is something that you can make use of in this Octave based simulation.